Welcome to the Tesla Motors Club podcast. My name is Seb.
I'm Doug.
And I'm Lewis.
On today's episode, Tesla acquires a wireless charging company, rumors about the Model 3 refresh, and Tesla AI gets its own Twitter account. Episode 44 starts now. Good to see you guys. Lewis, I think it's been a couple of versions of FSD since I've last seen you, but first of all, Doug, happy birthday.
Oh, no. Well, thank you.
That hat is fantastic, Seb. I love it.
I was looking for a party hat, like something more subtle, but that was all I could find, this big one.
Great.
Well, it's good to see you guys. We got a small group today. Mike's out. But I think we got some true experts here on a couple of the topics that we wanted to talk about today. So why don't we jump right in and talk about the acquisition that Tesla is planning to buy a German wireless charging company out of Freiburg. And I'd love to pick your brain on what that really means for the future of Tesla owners and the future of wireless charging. So Lewis, I think you did a little bit of research on the whole subject, didn't you?
Sure. Yeah, I mean, so I certainly have a lot of historical knowledge about wireless charging in general and just power and stuff with my background. But I have to say, at first I thought this kind of was a dumb idea. When you look at, wireless charging systems in the past, similar to how your phone works and, the wireless charging pads and all other types of things. The efficiency loss and other types of problems just don't really sound like they make much sense in scaling up. But reading some of the details around this company's technology, their claims, and big asterisk there, their claims, because I haven't seen any white papers, I haven't seen any concrete data on it. It sounds like it actually might not be that bad for what they're doing. So
what do they claim something better than 90% or what?
So they claim a top efficiency rating of 93%, which is way better than I would have expected, right? Like traditionally wireless charging, you're looking at like 60%, maybe 80s on the high end. But they're claiming 93% on the high end, which is like, okay, but what's your real world? And for that, they're claiming 91%. So only a 2% difference between their peak optimal and what they have. So 91% is pretty good. It's not, it's still not as good as plugging in my book. But.
Yeah, I mean, the question with that always is, why do you do wireless charging? Only if it's adds some convenience, right? If there's some reason that plugging in is a pain in the butt. I've always thought, when it was discussed, over a decade ago, and everybody wanted wireless charging because, we're going to forget to plug it in. I always thought if you're gonna go through the trouble of wireless charging, just have like some contacts below the car or something, and because conductive is obviously so much more efficient, right? And you could have a robot that would plug in the car. It doesn't need to be that snake robot. Probably you could do something with three joints would be able to align properly. Or you could even have, if the car is coming in, you could just have some kind of port cover that opens and some prongs that come up and charge the car from below. Because with wireless charging, you still need to be fairly precise about where you're parking for maximum efficiency. And I've seen some designs years ago where the coils would move to try to be more efficient, and maybe even the pad would extend upward because you're going to have I guess actually I don't know if it's probably one over R squared kind of fall off sort of thing.
Yeah.
So if you can have the charging pad either from the car extend down or from the floor extend up to make a closer proximity for that charging, that can increase your efficiency. But you're already going through the trouble of that. Why not just have some contacts that brush or something?
Yeah. So to get to some of the specifics, so what the company claims is for their I'll primarily talk about their 12 kilowatt system, because they have other charging systems, but if you're looking at like home charging for your car, 12 kilowatts going to line up with, your level 2 charger you get today.
Mhm.
And basically the distance of the pad to the from the sender to the receiver is basically, it has to be between 1.5 and 4 centimeters. So that's the like air gap distance between them of like how high your car could be over it. So when you're talking about, that's a pretty narrow margin. So if you're thinking about like, if your car has air suspension or if you have a lift kit versus raise and lowering, like you're going to have to make sure that that's situated correctly. And then on top of it, there's a plus or minus 7 centimeter distance from being oriented correctly. And if you're not within that 7 centimeter in either direction, you're not going to have very good efficiency.
Right.
So then you start getting into like, oh, when I pull into my spot or whatever, I got to get pretty accurate with that. So I'm not sure that Tesla, even buying this company, like I don't expect it to be something they're really planning for people to have at home, or even probably at superchargers anytime soon.
Well, yeah, I mean, at home is the only place where it makes sense because, okay, you talk about the loss. Wait, say it's 91%. At
Efficient,
12 kilowatts,
Mhm.
you're losing, a little more than a kilowatt of energy
Right.
is going to the air or heat or whatever, right? If you're supercharging, right? And supercharging rates are what, on the order of 250 kilowatts. You don't want to be losing like 25 kilowatts, right?
Right.
I mean, that's nuts. That's a ton
Sure.
of power going where?
And they don't even have a system that can go above 12. 12 is literally their highest volt or kilowatt system they have as a company that they've developed technology for.
Right.
So,
So
yeah.
yeah, I suppose it might be nice for people. You might worry about the cat if the cat wants to go into the car or something. With that buzzing through the cat. But yeah, invest in the robot. Make a little robot.
So part of me feels like this is really a push for the robotaxi thing, right? I think they're
Hmm.
they're kind of looking at it as, yeah, if you have a robotaxi, you have the system, the software driving it, positioning the car, even if it has to like readjust or whatever to get a perfect position, it's
Hmm.
not that big of a deal, and it likely can be more accurate than a person. I certainly wouldn't claim that I could nail that exact position every time driving,
Hmm.
right? You're gonna miss it here and there. So I feel like they're prepping for robotaxi, which is why they did this purchase.
Yeah,
But
okay, that could be it. Still, it's a slow rate. At
sure,
12 kilowatts, you're talking, for like a full charge, what? At least a couple
Overnight.
hours.
Yeah.
Not necessarily overnight. I think you could probably do it in well, we can figure it out. How big is the battery? Let's say the battery's 90 or something, right? Okay, so that's 8 hours or so. So yeah, overnight, I guess. Yeah, yeah. I mean, is there
well,
some
you,
and there's
you got
some
to keep
other
in mind
technology?
there's other losses too, though, right? So like it's probably worse than that. Just even just doing napkin math, because
Hmm.
technically what a lot of folks don't realize is they're losing a certain percentage off the top of their charging at home, just because it's got to do the battery temperature, climate control, all those types of things. The
And
numbers
even
I've usually
the
seen is like 300 watts or so.
yeah, there's
um
a AC/DC conversion as well, and
exactly,
there's a bunch
AC/DC
of other stuff.
converter has a loss.
Hmm.
So yeah, so you're not getting, so even if this was 91%, you're still not getting 91%, you're getting less than that. So
Yeah, well, order of magnitude. It's still, yeah, it's like an overnight charge for a full charge. Um, so yeah, is there some other technology that this company has that Tesla might be interested in? That some other
um
reason besides say
they
wireless
have
vehicle charging?
So they have battery systems, which they definitely they have like some different power storage options. I can't imagine their battery systems are as advanced as what Tesla has in house already. It's possible they might have something unique there that I haven't seen information about. Um, They're doing they do have like lithium iron phosphate type batteries. Tesla already has that. They were doing some other titanate batteries, lithium titanate batteries. So maybe that could have been a play for it. But most of their offerings are really around wireless charging systems and autonomous charging systems for like robot, self-driving type things, like pulling in, or like factory forklifts, things like that. Driving over pads.
Oh,
So
maybe Optimus, huh?
it is, yes, it's very possible that this is an Optimus.
But you would
play.
think Optimus would be able to grab a charger and plug it in, right?
Yeah. Certainly. And I do think it's interesting that they like their latest kind of product was really around going up to a 12 kilowatt hour charge, which kind of aligns with the Tesla home charger. So it's kind of like probably going for the home charger play, but yeah, I don't know. It'll be interesting. It time wise, right? Like I feel like it's going to take a while. It's like when you buy a company, it doesn't happen overnight. Integrating things, you leveraging their technologies. So I think we have some time before we actually hear of anything real coming out of this. But I don't know. I'm kind of with you, Doug. I'd probably go for, I'd want an automated like Conic thing. What happened to the snake? Remember the snake? Can we go back to that? Like what?
Well, I think the snake was some grad school project of somebody that then went to go work at Tesla, and they tried to, they just acted like, ooh, here's this cool thing we're working on. There's a comment from Electrified Light Vehicles, and he said, the affluent folks will shell out 10 to 20K for an installation in their garage, I suppose. And he's right about that. It could just be a product, an option. But Tesla, Tesla tends not to like custom hardware, like
low volume products.
Yeah. So, I mean, because if it were just a thing in the garage, but the fact that you would need something under the car that would also have to wire into the batteries. Yeah, that's interesting though. Because what is needed on the other side of the coil? Do you have any like? Do you know what frequency it's?
I don't know what frequency specifically theirs is transmitting at. Yeah, I mean it's basically two coils, right? They've got one on each side, and their coils are wrapped the windings so that they have they're basically gonna
so
be
oscillating
at the same frequency. They're oscillating.
There's oscillating magnetic field.
It's similar to what like power transformers do, right? The difference is large power transformers, they're running at efficiencies of like 99%. So if you look at like the U.S. power grid, for example, across the board, the U.S. power grid loses about 5% of all power generation.
Right. Well, their efficiency is because they're doing very high voltage.
Correct.
So they don't have as much.
And they're very small air gaps, and they're able to be, insulating, controlled. You wouldn't want that type of magnetic field in your garage, right? It's going to interfere with other things.
Right.
So they're limited in what they can do.
Well, I'm just thinking because even those high voltage things, they're running at 60 hertz, maybe three phase, they're still 60 hertz. So I'm just wondering what needs to be between the coil on the car and the hardware that's already there. Like, will they get, if they're running at 60 hertz, can they get and it will be AC. Can you just take that 60 hertz AC signal and put it into the charger that actually is on the car that does the AC to DC conversion?
I definitely saw some hints that they might do that, where instead of it being like a special thing that like you have under your car all the time, or like a special thing under your car that's wiring into the battery somehow, is that it might literally just be going into the charger, into the normal charge port, and it just connects to a plate, which would look kind of stupid, but it would it'd be way cheesy. So I can't imagine Elon going for that. But there was definitely, I think that they did that for like early experimentation, right? They definitely looked at how could we, wire that in.
Well, you guys make good points. Initially I was asking myself, where are we going to see this product? And it's not going to be at the grocery store. It's too slow. There's no ROI. It's not good for level 3 charging. So I think, Lewis, you make a good point. This is probably laying the foundation for the robotaxis, right? when you have a big fleet that's just pulling into a warehouse and it can charge overnight. We should probably give a quick shout out or update on Rivian now also going all in on the NACS standard, right? So who's left now? I guess Lucid's not adopted it, and Doug, you mentioned there's been some comment from the CEO.
Well, yeah, I assume Lucid is sour grapes. Lucid, the guy Peter Rawlinson is his name, and I remember him. He had a couple neat videos showing how the chassis of the Model S, and this was shortly before Model S production, and then he was let go like at a critical time. And you see this often with Tesla, actually. A major executive is let go at a critical time in the company, and you just have to wonder, what's going on there. But yeah, he's now the CEO of Lucid. Lucid, they feel kind of on the edge to me as a company. They need to get their volume up. They have a very expensive vehicle. It's nice. It's like they thought of everything, but they're competing with Tesla that sells an as nice car, not as nice interior wise and thoughtfulness in terms of the features, but certainly more reliable software, say, and certainly a better prospect for longevity as a company. And their car is so much more expensive. I think it's going to be hard for them to compete. And so them not, I would think NACS would be win-win for them, since they don't begin to have the resources to start investing in something like Rivian's adventure network. But it just feels like sour grapes. He said something like, well, they do it if the Tesla standard could support 1,000 volts or something like.
Yeah.
Come on. What are you expecting? Like what infrastructure is there that it does that now? And you're going to wait to come on. Doesn't make any sense.
Yeah.
So, but
yeah, I think it's weird, or I was just gonna say, I think it's weird that I agree with you. The whole, it seems more personal than practical. And like, I looked at Lucids when I bought my Plaid. I was like considering, like, do I get a Lucid Air? It's a similar price point. The Air is a little bit more, and it has some nice features, but it's like, one, I think the car is just uglier. I don't think it looks as nice as a Tesla. Two, for the price, the performance isn't there. Maybe the $250,000 one can compete with the Plaid, maybe, but it's $100K difference in price. And yeah, it has all like the massage seats and the the nicer interior, but it's also got a lot of trappings similar to older cars, right?
Mm-hmm.
Like classic cars. It's got more buttons and knobs and things, and it looks busier. And it's not, aesthetically they don't look nice. But yeah, they already have price issues. The NACS from our last show, right, or we talked about it last time, it's cheaper, right? It's come out and said it would be cheaper to manufacture the cars, and it would open up and it would incentivize people to buy them. So it's kind of like a no-brainer. They should do it, but at this point, they're just holding out. I think they'll eventually give in. I think they're gonna have market pressure. They won't have a choice. But
yeah,
it's a gift for a small company,
right?
It's a gift, right? To be able to use that connector and that infrastructure that Tesla has provided. So you're nuts if you're not going to do it. If you're Ford or GM, and you got, I don't know, money sloshes around wherever. I mean, obviously those companies have have their own financial troubles, but there's enough money in the system that it can sort of move around and they can make sort of decisions. But if your existence is on the line, you take every advantage you can get. So even if you see Rawlinson, I guess it was in some interview, like it might have been CNBC or something like that. Just listening to him talk, it even sounds like sour grapes. He's just trying to find a way to criticize it. Though I'll say, some of what I've heard people talking about the standard, and again we've gone on a tangent about it. That the Tesla connector is more robust and that sort of thing. I'm not sure that it necessarily is. Tesla actively maintains the supercharger, so those are when one is down, it's seems to be fixed relatively quickly. If you look at the destination chargers at hotels, and basically those are the same as the units that they'll sell at home to people, to use at home. And a hotel will just sort of put them up on pedestals, outside, and it's a perk to get people to stay there. But they do not maintain those very well. And I've seen horror shows there in terms of the connectors and what they look like. It's just no good, really. And if you think about how the connector is, it's plastic. I think it could break if you drop it hard enough or someone runs over it. And then the button that is on where you press with your thumb, that's on flexible plastic. That's going to have a lifetime. And so I've seen connectors where the whole top is gone and you sort of see electronics underneath. I've seen connectors where the whole front is ripped off and you just have these bare, connections, like without the plastic housing. Doesn't look great. Anyway, and I still think it's a better standard. And it could be made probably with harder plastics and get rid of that flexi button. It's not really needed anyway. So I'd be interested, especially if the standard's opening up, as third parties make their own sort of charging systems with Tesla connectors, if they'll try to make them more robust, or we'll see how it actually pans out, I guess.
Yeah. I think those ones are great for the house in your garage, but just not that good for destination charging because they're just being manhandled by everybody. But Duck, you made a good point, right? Lucid on the one hand, low volume, kind of luxury, even more expensive than the Plaid, actually double the price at this point. And then Tesla has super high volume, great looking cars, definitely very competitive to someone who's shopping for an electric vehicle, right? They might not want that extra luxury that the Lucid may have or that a Mercedes EQS may have. And it seems the Model 3 is going to get even more attractive, right? So we saw some rumors about the refresh. Doug, Lewis, what do you guys think?
Yeah. What were those rumors? So we've seen, and we've talked about it on the show a couple times about the Highland update. We've seen some styling things in terms of how it looks in the front. We've also seen like maybe some different lights on the front. We've seen the interior, which it looks like it's adopted the changes that the SNX have had in terms of losing the stalks, the steering stalks, and the capacitive buttons on the steering wheel. But we've gotten some rumors, I guess, from, let's see, who was it? Let me see if I can share this now. Let's see. Does this work? There you go. So from Tesla Scope on Twitter, and I'll say they're rumors because the things they mention, some are relatively realistic, like RGB lighting, the hardware 4, and we've already seen hardware 4 cameras on other vehicles, sort of with the sapphire, the red sort of lenses, and we've seen some nice things too, like that the images from the cameras look more human consumable, like the colors are proper RGB. But also included in these rumors is that the steer by wire, and we should say that Tesla put a patent recently for steer by wire instead of standard steering, and I simply don't believe that is coming anytime soon, just because of regulation. I mean,
if you're not the only one.
Yeah, if Tesla can't even, Tesla's wanted to replace the side view mirrors with cameras. And your steering is such a larger safety concern than the cameras. Than the mirrors. Then I just I don't see it happening anytime soon. That needs to be tested and everything. So.
And Doug, I asked you this earlier, but when Porsche and some other manufacturers initially went from hydraulic to electric steering, I falsely assumed that actually was steering by wire. But you explained it pretty well. Maybe to folks who are listening and don't know all the differences, could you maybe explain electric versus steer by wire?
Yeah, sure. This has been a general trend with vehicles over the last couple decades, that things that used to be a pump that ran off the engine, they just get replaced by an electric motor. So your power steering used to be, you had power steering fluid that you had to, make sure it was topped off, and it's a hydraulic system. And so when you turn the wheel of your car, there's a hydraulic assist that helps you turn the wheels. And if anyone who's driven an old manual transmission that doesn't have power steering, it really makes a difference when you're trying to park. When you're barely moving, you're trying to turn the wheel, you really have to muscle it. So power steering was sort of a luxury item at first, and now it's pretty much standard in any vehicle. And in recent years, it's no longer hydraulic. You're no longer worrying about power steering fluid. There's a separate motor that's giving you a power assist when you turn the wheel. There's a motor that's helping you turn as you turn the steering wheel. It's helping you turn the front wheels of the car. But that car still has there's a steering column that comes directly from the steering wheel all the way to typically a rack and pinion system, that you have a pinion and you have a rack. So it's like a gear that goes into a linear teeth, and that moves the wheels, left and right as you turn the steering wheel. And that is a major safety issue. You need to always be able to steer the car. You could have the engine die. And I've had experience where, I'm driving a manual transmission and the car stalled and I still needed to steer. So you have to really manhandle it to steer, but you can still steer. You're still able to steer because you have a physical connection between the steering wheel and the tires. In a steer-by-wire system, you have a steering wheel, but that steering wheel might as well be your PS3 controller when you're playing Gran Turismo or something, right? You're sending a signal when you turn the wheel. There's some electrical or coded digital signal that then goes to a computer that then tells that probably a very similar motor to turn the front wheels. And so that's a major safety concern. If that died, what would you do? How would you be able to steer? So braking and steering is always important in a car. Assuming that everything dies, you need to still be able to do those things to safely make it to where you're trying to go, or to avoid an accident or whatever.
Makes sense. So does that mean they have to put force feedback in, like an old Logitech PlayStation wheel from the 90s?
Yeah, they'd have to. Otherwise, it would feel really dead. Yeah, they definitely would. But that opens up so many things if they could do that, though, right? We already talked about in previous weeks how Tesla isn't doing right-hand drive Model S and X's in those countries that have right-hand drive, like the UK and Ireland and Australia, for example. But they still sell plenty of Model Ys and Model 3s in those locations. If you could have steer-by-wire, having a right versus left hand drive would be a pretty simple thing to swap. It's like hand the controller to the guy to your right or whatever, and it would be that simple. So it'd really allow them to lose a bunch of parts, heavy parts too. Might even be a safety thing, because in crashes often you have the steering column is right in front of the driver, and that's something you slam into, which is why that's a normal place to put the airbag. But you could have the airbag, just on the dash, and not have this hard thing that's closer to people to slam into. It'd be great if they can do it, but it would. And I haven't seen the patent, and I assume since these kind of things have existed on kind of experimental vehicles for a while, I assume the patent has to do with how to do this safely. And as we were chatting earlier, and as Lewis suggested, it would have to have its own power supply. It would also have to have some redundancy going on. If one part of the system fails, it needs to have something else. And
what's interesting is I did find the patent. I was looking at it some. They do have force feedback actuators, right? So all that kind of stuff is in there, in their diagrams. There's actual multiple actuators for feedback. They do have a power supply. They have it looks like it's a 30 amp power, something like that. It says power 30A. So I don't know if that's supposed to be amperage or that's referencing something else. Might just be a number for the diagram, but they do have their own power supply. In fact, there's two power supplies.
That
So
makes
there is
sense.
redundant power supplies. They have multiple CAN connections. And yeah, so there's definitely redundancy in the system. And I imagine any kind of microcontroller embedded system, it's not going to be like it's running on like embedded Windows or something, right? Like this is going to be a real time, no OS or a real time OS based system with interrupts. It's going to be it's going to be something that's optimized for safety critical systems, similar to like you'll have an aircraft. But I don't see, NHTSA approving this quickly, right? So like they've been working on it for a while. I think the original news of this coming out was, maybe 2 years ago or something, that they were going to work on it. Elon said something about like they'd like to get there. And there was more updates on it last year. I think like last fall, November timeframe. There were people talking about it again of like, oh, they're working on this. They had like a team, I guess, in the Austin area, possibly they hired for to try to work on this. But I mean, yeah, they're working on it for sure. They definitely want to do it. Where it came from people saying like, oh, it's going to be in Project Highland.
Yeah, don't believe it.
I don't believe it. It's possible. I don't want to say it's impossible, but it's very unlikely.
Yeah, and the main motivation is obviously for the robotaxi, right? If you have a robotaxi and the person in that driver's seat doesn't need to drive, you could have the like the wheel could like flip up or just absorb into the dash and just go away. And I mean, that was part of the speculation about going to a yoke. It's this narrower thing that could just kind of melt into the dash and then it just goes away when you don't need it. That's part of the reason getting rid of the stalks. And the only reason we have the wheel back as default is because enough people were annoyed with the yoke. And as I've said in the past, Elon lives in the future, so he'll do these things, make these changes now in preparation for something that, in his head is 2 weeks from now, but, is really maybe, I don't know, 2 years or more from now. So,
sure.
Yeah. Mostly seems like a research project, right? Some R&D, future proofing. Robotaxis are going to be here at some point.
Right.
I think we do have a little more substantial updates and evidence about the AI, right? Work that Tesla is doing.
Let me, real quick, let me answer this question since it's still on this topic. Mike,
I asked you that earlier, right?
Oh, you did.
Yeah.
Mike asks, don't airplanes use fly-by-wire? Yes, most modern airplanes do, but you still have some airplanes that fly by cable. Basically, you pull the stick and that pulls a cable that is fed through a bunch of tubes or whatever to whatever aerodynamic surface needs to be adjusted. Fly-by-wire probably first came with fighter planes where the force needed to be able to adjust that surface, and you're going so fast that it wants to be pushed back down. You needed some electrical assistance to do that, and you also have very complicated systems now. Most modern aircraft practically fly themselves because they're aerodynamically unstable. So a person without the computers couldn't just fly it. So you have a bunch of adjustments that will happen that the pilot isn't even doing. So yeah, most modern aircraft are fly by wire, certainly any modern airliner, but there's still older crafts flying, stunt crafts, little biplanes to do stuff, and a lot of those will still be cable. That was fly by wire because of the wire that's running to the to the actual surface that you need to move around. So,
well, not to go into. Sorry, go ahead, Louis.
I was just going to say, the thing to keep in mind though is it's in an aircraft, it's somewhat easier, I would say, to do, in the sense that one, they're way more expensive, so they can put a lot more money into testing and safety and hardware and all the other stuff involved in the software development. But also, most of the time when flying a plane, it's not that critical that you're super focused on having like fine-tuned control, right? Like as Doug said, most of the planes are flying themselves, but like the plane isn't, a few feet away from somebody else or something else. You're not turning as much all the time, right? There's critical points of landing and takeoff where you need to have good control. But like if something goes wrong with the computer, or other systems or checks, they can reboot. They can do things in the process of you flying the plane. The pilots have breaker panels and switches where they'll restart things or do stuff like that. In your car, you don't really want that to happen when you're when you're making a turn on the highway, right? Like you're much more likely to have a problem if it fails. There's way more time for it to, you don't have as much time to remedy a problem, I should say.
I would just say, I would also add that it's in many aircraft, it's actually just a necessity. I mean,
right.
You're here and you're like, I don't know, 100 yards from the control surface, and that cable, whatever cable is going to have enough slip that you're going to have good control. So, by necessity, like a modern airline or whatever, a lot of those controls need to be controlled by wire, obviously.
Yeah. True.
Interesting. Well, I did want to ask you guys about the next topic, which is the update on Tesla AI. It now has its own Twitter account. And I think there's some substantial Dojo updates that you were telling us about, Lewis, right?
There's definitely some Dojo news. First I'll just say that it's interesting that Tesla now, I guess it's part of Elon, purchasing Twitter. He's having more Twitter accounts inside Tesla. So the Tesla AI team has their own Twitter account now, where they are posting and publishing news directly about their stuff. Part of this is to recruit. They're definitely constantly bringing up like, hey, we're hiring, right? Join the team. See, there's if you're watching on the screen, there's an example there. So it is interesting. We do have a source of information directly from the team. A lot of stuff on them working on Dojo, going to conferences, those types of things.
And they talk about Optimus a lot, which, Optimus to me is mainly a recruiting tool, right?
A recruiting tool, yeah. So, Optimus is certainly, featured on there. And there's cool videos. There's cool examples of, some of the software they're developing with the AI. As far as how meaningful or practical most of this stuff is, probably not, right? Like it's just cool. We get to see a little tidbit here and there. Does it give us any real insight into how close they are to, full self-driving, truly working, being level 4s? Like, no, it's not giving us any real detail there. The most interesting thing I saw on the feed so far was about Dojo. They basically have a chart where they're basically talking about how they're going to be, it's the title of the chart is trained on extremely large compute, and they have a timeline. It's kind of like their roadmap of their compute. And basically, on one axis you have, the number of GPUs. So they convert it into a unit they call the A100 GPU. A100s are kind of a standard GPU used for machine learning. It's the type of GPU that a chat GPT would have been trained on, and other types of, common, if you buy video card compute engine in the cloud, you'll frequently, you'll be thinking in A100 GPUs. Anyway, so they have the number of A100 GPUs, and then they have over time and where they are. And basically the information that came out of it is, it says essentially next month, so July in 2023, it says start of Dojo production. So, we've talked about Dojo in the past. I think what this means, and again, we're interpreting it, so we don't know explicitly what this means, but I think what this means is the start of using Dojo in production and not the start of producing Dojo. Although this chart does kind of look like a yield curve over time of like manufacturing chips and how many chips they would get. But I think what it is they have a certain size of Dojo created. They've done experiments. They've been playing with it. And Dojo, again, for those that aren't in the know, this is that big supercomputer cluster they're building to do all their training for their models for full self-driving. And so basically, I think they're going to start using it in production next month is the plan. And then they show this curve. It's super linear. It's almost verging on looking like they're going to try to be exponential, which is essentially impossible. So that's not going to be truly exponential. but it basically where you're seeing it go up on to the right as time goes on, and they're essentially planning on by October 2024, they're saying they're going to hit 100 exaflops, which is just a it's floating point operations per second. It's just a way to measure how quote unquote powerful their supercomputer cluster is. Now, and to give it numbers of like A100s, that would be about 300,000 A100s. Right now, where they're at is more in like the, maybe 10,000 A100 range, 5,000 A100 range. So, yeah, they're expecting to have a lot more compute and power. And, they claim they're going to projecting themselves by, early 2024 to be in the top 5 supercomputer performance clusters in the world. So like basically they'll be in the top 5 power of flops for compared to all the other supercomputers. Now that's a big stretch. There's other computers. They're going to be upgraded. More things are going to come out. This is a projection, so that may not hold true. And also there's a big question on if they'll be able to maintain it, hit this rate of getting chips online, building out their cluster. There's lots of challenges in building these things. You can have failures. You can have, manufacturing defects in the chips, right? They might discover a flaw, or, their yields might be hard to hit. I believe TSMC is making their chips for them. They might not be able to make the chips fast enough. There could be a shortage. And there's a million variables. But anyway, it's cool to see Tesla's plan. And it is an impressive amount of compute. It is interesting to see what they're targeting. It's definitely ambitious, but Tesla always is, specifically Elon.
I guess just to clarify, like exa, that's the SI
Yeah.
prefix for 10 to the 18, right?
So that's 10 to 18. So very big number, lots of zeros, 18 zeros.
Well, just so, I mean, people can think about mega and giga, right? Giga is like a million something, right? Then tera is I'm sorry, giga is a billion something, tera is a trillion something. So then you have peta, then exa. So exa is like a million tera. So if you have like a 2 terabyte drive, and on AWS, I have an exabyte drive or whatever. That's a million terabytes, right?
Right.
So in terms of how do I compare that to something more down to earth? Like if I have a RTX GPU, like or whatever, like how many teraflops?
I mean,
whatever
so it'll definitely play Crysis if that's what you're asking.
Yeah.
No, sorry, that's an old video card joke. In keeping in mind, it's basically they're going to have the equivalent of hundreds of thousands of video cards be able to do machine learning, or the performance of those. Now, what does that mean? I mean, could they, are they going to use all 300,000 to train the FSD model? No, that's not how things work with machine learning. They're usually, what they're doing is they have these problems and they break these problems up into small pieces and they kind of run them in parallel. And then they also do lots of different versions of them. So they generally they call them experiments. It is, under the name of data science. So they try to pretend they're doing actual science by saying they run experiments. So basically what it'll allow them to do is they'll be able to try many different things. They'll be able to train lots of different models, have multiple teams even working in parallel, to where those back in the day, they used to do things like, you'd have to share compute time, right? If you ever worked in a mainframes world, or, in performance computing world, as I'm sure Doug probably ran into with physics, as I have myself, well, there's also the physics background. You have a problem and you go, hey, I want to run this. I want to figure this out. It's going to take, X hours or days or whatever of computer time. Well, I'm not allowed to use the computer. Somebody else is using it. So I got to wait. So you submit your thing and eventually you get to use it. This amount of performance, this amount of thing, basically you're not going to have people sitting around waiting, right? You're going to have teams of engineers able to do a lot of experiments in parallel and try a lot of things.
So essentially they have their own, high compute cluster. There's been some, I guess this info basically came out at AI Day. Did they say where they're going to house this thing? Is it going to be in Palo Alto or?
That's a good question. I actually don't know where it's being housed specifically.
There's
It's
that new
probably
space in Palo Alto that used to be HP, and I drove by there once, and there was hardly anybody there after they did that official opening.
yeah. If I had to guess, that's probably where it'll be, but I don't know that definitively. And yeah, and to give some numbers, so thanks, Seb, he pulled up, so like if you were to look at anyone that's familiar with video cards, like a GeForce RTX 4090, that's kind of like one of the creme de la creme high-end gaming video cards right now. They're what, they're like $1,600, $2,000, something in that ballpark is how much that video card does 83 teraflops.
Right. So we're talking about 1 million times that.
1 million times that.
By
So yeah,
October
so it'd be like
24th.
having 1 million of those. But the other thing to keep in mind, the important thing compared to like a normal desktop GPU versus something like what Dojo's doing is they're able to be way more scalable. Obviously, you can't just plug in 1 million RTX 4090s. That's not going to work. But it also, even if you could, it would be incredibly inefficient. You're going to waste a ton of power. You're going to generate a ton of heat. It's going to fail. It's going to be, problematic. They've designed their system to be very dynamically scalable, power efficient, heat efficient, which directly plays into power, and memory. Memory is a huge factor. So for those of you that, familiar with things like ChatGPT and stuff like that, what people don't realize is to train those things, you need a lot of memory, a lot of RAM, specifically video RAM on your cards to make it not be terrible. So that's one of those big things of they're going to have a lot of memory bandwidth and a lot of RAM available to the system. So they'll be able to process more video in parallel and do more training in parallel. Now, what does all this mean? Really, all it really means is, hey, they're going to have a lot of capability, a lot of powerful tool in their disposal. They'll have a lot of just really powerful machines to do the work that they kind of want to do. Does that mean that they're gonna we're gonna have FSD, the end of this year or something? We're gonna be level 5 next year? Like, no. It's not just the tool. I mean, that's one of the requirements. So this is a huge enabler. It's also how you use it. So you can use it effectively or not. And it's also going to be on, what other roadblocks or things they run into, right? It's at the end of the day, as most of us, Elon has said, it's really a software problem, right? He kind of looks at it as it's a software problem. It's mostly a software problem. There's hardware problems too. Power and efficiency. There's, the car is limited power. This cameras only can see so much. All those types of things. There are hardware limitations, but if we could magically like wave a wand and have the perfect software of like how you could do it, it's very possible the hardware today could do it. And so the question is, will they be able to develop that software with this system? Maybe. No one really knows. But anyway, so it's still impressive to see.
Well, that's a good point, Lewis, too. Go ahead, sir.
Go ahead.
I was going to say that's a good point you made, Lewis, because earlier you mentioned, and Mike actually put a question in the chat. He was asking, what is this being trained on? Like, what's being used to train this? And the point you made earlier was that even though Google has more resources than the developers of ChatGPT, BART was inferior, right? So what is this being trained on? And
I mean, it's easy when it comes to machine learning and AI, right? There's a few metrics out there that people like to think of like how many video cards did it train on, right? Like people throw those things around. Oh, we used 10,000 A100s. Oh, we used 20,000 A100s. It's like, okay, that's really a function of time. You could do it with one A100. It might just take you, 100 years around the clock. So the more video cards means you can do something faster. And then there's things like parameters. How many hyperparameters does the model have? And, when you look at things like, ChatGPT and the architecture, like ChatGPT was built on transformers. Did OpenAI, the company behind Chat, did they develop transformers? No, Google did. So Google developed transformers first. They were the actual like mechanism that they used primarily came out of Google. Okay. Did they have more GPUs and more compute? No, Google does. Google has way more money than OpenAI, right? Like they had all that thing, but OpenAI found a way to use it more effectively. They found a way to do something more interesting with it. And they even had fewer parameters, right? What's it called? Palm had more hyperparameters than ChatGPT, or than I should say GPT-4 did. Yet GPT-4 was outperforming them by a lot. Now, again, Google's learned from that and has caught up. Bard is doing much better today than it used to. But it's how you use it. It's not just I have more, I win. Somebody else could come along with a lot less and do better. If you think about it, the human brain uses way less power than your desktop computer, let alone a supercomputer cluster. These supercomputer clusters basically need a power plant to run them. So, there's a whole orders of magnitude of efficiency of how much energy does it take to do it and how efficient are you. And we're just trying to get it to work. Tesla's trying to just make it work at this point. Once they do, we'll hopefully come up with ways to make it more efficient and better. But who knows? We may still be 10 years out before this sees any fruit.
Now, so Tesla, assuming they build everything that they plan to, they're going to have quite a lot of compute, available. I assume they build it, assuming they're going to use all of it. But there has been some talk if they have, extra compute, they could sort of sell it like an AWS kind of thing. Is that likely at all?
I honestly think so. When you look at these projections and things, so one, Tesla's always looking for ways to increase their market cap, as most public companies are. But I would say Elon and Tesla, they leverage this capability a lot more. And how do you do that? You do that with perception. You do that with actually making money, right? Like selling goods. And having a product line or another product line where you can go, oh, it's real low cost for us and we can make a high ROI, right? Like AWS is one of the most valuable assets that Amazon has. Amazon's one of the other most valuable companies in the world. So if Tesla turns around and goes, oh, by the way, we have this amazing supercomputer cluster that's better than anybody else, and you can train your ChatGPT competitor on our stuff. Guess what? Companies will line up to pay money, and Tesla's stock price will shoot up.
It seems like pretty specialized hardware though. And then if you have customers now, you have to provide them with some kind of interface, and then maybe even a framework, like a software framework, from which they need to work.
So they have that internally. So keep in mind, Tesla's internal developers are using some standard open source libraries out there. They're using things like PyTorch and stuff like that. And what we got to see in the AI Day type presentations is Tesla in-house, they are working on compilers and tooling and things where basically they're able to take, tensor-based models that are developed in something like PyTorch and run it on their architecture by using like specialized compilers and transpilers and things like that. So I kind of view it similar to like Google. They have their TPU, which is their specialized machine learning hardware. I think Tesla, they're also developing those software tools. And yeah, is it a question, can they just like push a button and other people can use it? Okay, it's not that easy. Maybe they have to write better documentation. They maybe have to, provide some additional support. But I do see it as a possible future where they go, yeah, we've got this awesome hardware platform. We've got the software tooling. You write your models in this way. And maybe it won't be good for everything, right? However, neural nets and anything that's using transformers, and certainly anything that's doing video processing, can probably map pretty effectively to their platform. So that's a big problem space. There's a big domain. Lots of things can map to that.
Yeah, that's interesting. AWS was almost an accident, right? They had all this extra capacity to sell products on Amazon over Christmas, and then most of the year that compute's sat fallow. And it's like, okay, let's start time sharing, and that's a big business. I mean, we use it. TMC runs on it. So
insane margins.
Yeah, so it'd be interesting if Tesla got to the point where they're building clusters for the public or whatever, as opposed to beyond what they use themselves.
I mean, who would have thought that they were design their own chips even, right? Like, if you think about it, Ford isn't designing chips, right? Like you've got Volkswagen isn't designing chips. Tesla's designed their own chips. They have TSMC. They're one of their biggest customers, I think, at this point, asking, tons of high volumes, lots of chips, bleeding edge technology being developed. So Tesla's not afraid to get their hands dirty and move into these full vertical or even like parallel markets of, power distribution and all the other stuff that they've done. So it's definitely a possible revenue generator.
Cool. So was there anything else in this Tesla AI Twitter that's worth mentioning? Anything else of interest here?
Not really. I mean, a few things where they talk about, they show examples of like how they can leverage this stuff for both Optimus Bot versus the cars and some of their updated driving models and pathfinding. But no, it's mostly just advertising for people. What I think there'll be really cool and interesting stuff in the future. So I think we'll keep an eye on it. We want to watch this handle for sure. But yeah, at the moment, I think the Dojo stuff was the biggest, most interesting news.
Cool.
Awesome, guys. Any other thoughts before we wrap it up for the day?
Let's just see if there are any questions that needed answering here. Let's see. Electrified light vehicles. If FSD will be a level 3, 4, or 5 by the end of this year, as per Elon's remarks on earning call, wouldn't Tesla apply for higher level autonomy for their models on the road? I would say, what are they, level 2 right now? Is that, I mean, the main thing is liability, right? Why they don't claim to be anything more than in a driver's assistance system, right?
I think they claim to be like 2.5, but that's because that doesn't mean anything.
A thing that doesn't exist. Yeah.
Right. Exactly. Yeah. I mean, if you look at Elon's actions in the past and how Tesla is, what I would say is Elon will claim that they are level 3 before by any legal definition of them being level 3. So yes, I agree with you. Tesla would have to apply for higher level autonomy for their stuff on the road if they were going to actually do it by the end of this year. I think from Elon's position, and this is, and again, I'm putting words in his mouth, but it's my educated guess. But I kind of agree with this. Is if I was him, I'd consider it a win to say, yeah, we think we're level 3, even if the regulatory body hasn't signed off on it yet, right? Like if you're like, yeah, the paperwork's being done, we won't officially be level 3 until mid next year. But if you're looking at it going, the tech is there, I think they'd count that. He would count that as a win and not saying he missed the deadline of his, by the end of the year. I'm not seeing that happening currently. We have, FSD 11.4.4 has come out. And as all FSD versions, it's some things might be better, some things might be worse. I haven't driven with it much yet myself, but I still think we're pretty far away from saying we're level 3.
Yeah. I got it also, and I haven't really used it yet. And I haven't, there are a couple tricky situations like turning left across a lot of traffic. And I'm not ready to trust it, mainly because I'm just trying to get where I'm trying to go, as opposed to run it through some testing regime, so I'm not willing to risk and wait just quite yet, particularly if I have
Doug, you're a content creator.
Not really. Let's see. Same guy asked another question earlier that when we're talking about the drive-by-wire electrified light vehicles, said, being frank, most new drivers won't be able to learn driving adequately with steer-by-wire. I don't know that that's true. Certainly, when I'm playing a video game, it's not that great, mainly because I don't have the G-forces of turning. But if you are pretty good about putting in force feedback, I don't know how good it would be. It's certainly, driving feel, that's a big thing in cars, right? Particularly with a sports car, you want to feel what's in the road. So the force feedback is really important. But the reason you have force feedback is because there's something pushing the wheels as you're trying to drive. And if they have some transducers and things, measuring that kind of stuff, you could bring that back into the wheel, and it would be at the speed of light. So, it should be, it could be done. So I don't know that I necessarily agree with that. Yeah, you don't want the steering to feel dead. That would be sad, right? But anybody have any other opinions on that?
I mean, to be fair though, he's not wrong. In the early systems, they were terrible, right? So like,
yeah, definitely.
You're spot on with early examples of these types of systems. They're awful because they don't give you the feedback. In their patent, they do mention multiple things for feedback, The question is, how good does that operate? And I agree with Doug. Like I guess I'm a believer in, the matrix of, if you can fully simulate it and fake it, then you person won't be able to tell the difference. So.
Well, also in the spirit of the question, I think by the time this is mature, I don't know if people are still learning how to drive, like going 50 years into the future.
That's fair, Seb.
And I know if things actually go the way they expect, maybe they won't even need to learn how to drive. Steve Jervison gave a talk at our 2014 event. That was almost 10 years ago, which is scary now. And he did a great talk. And part of it was talking about, they didn't call it FSD back then. They just called it self-driving. They didn't have to add full self-driving. They didn't have to intensify it.
Well, that's why they have to call this full, because that one was called self-driving and it didn't.
That was just called autopilot or self-driving. But he had a kid at the time, and the way predictions were at that time, he was thinking this kid wouldn't even need to learn how to drive necessarily. Now it's funny because that kid ended up going to Stanford, and I remember seeing him at like some activity fair, and so yeah, that didn't happen. So a good number of years passed, and I'm sure that kid had to learn how to drive. But I mean, if things go the way they want, and the main reason that Elon is even having a drive-by-wire is that maybe robotaxis will come along, and maybe kids won't necessarily need to learn how to drive. I mean, any cool kid will learn how to drive, but maybe they won't need to.
Right. Any other questions?
Nope.
All righty. Well, we'll make sure to keep you guys updated on any future versions of FSD, obviously, any updates on Tesla AI. So I'd say that's a wrap. Thanks to our producers, Adam and Danny. And thank you all for joining. If you want to follow us on social media, you can do so on Twitter and YouTube. And if you want to support the show, please consider becoming a supporting member. And you can, of course, join us on the Tesla Motors website. So with that, it was good seeing you guys.